When we think of computer networks, the word telecommunications comes to our mind. The word tele means remote, and the word communication describes communication technologies and communication devices such as telephone, telegraph, television, etc. These two words were brought together and the word telecommunications was formed. And we also use the word telecom as the short form of telecommunications. Telecom is the transmission of the data by various types of technologies over wire, radio, optical, or other electromagnetic systems. Today that the term of telecom infrastructure has come to encompass all terminologies and the technologies used for data transmission. With the devices for the communication between the sender and the receiver, user data is transmitted mutually over computer networks. In this context, the basic structures and devices that enable the transport of user data can be examined under 5 main headings. These are computer network, network devices, data transmission, source device, and destination device. Computer network enables remote devices to communicate with each other using spatial hardware, spatial software, and spatial technologies. When the computers are connected to each other by using network, they communicate with each other to collaborate and share their resources. Thus, safe and efficient use of shared files, hardwares, and softwares can be ensured. Authorization-based computer networks between computers also make administration and support tasks easily. In this way, network administrator can manage other computers on the network from one place. Network devices are specially equipped devices that communicate with each other by using fixed or modular network interface cards, NIC cards, on the computer network. A network device is an independent component of network that participates in one or more protocol layers that includes edge devices, routers, switches, network interface cards, computers, servers, network printers, and other connected devices. Each network device has a NIC card, network interface card, that connects that device to the network. The network interface card has a MAC address and IP address to identify itself to the network. By using these addresses, request data packets can reach the destination address, and also response data packets can reach the other side of the computer network. MAC address is the hardware fixed address that is assigned at the factory when the device is manufactured, and it can never be changed. MAC addresses are like the citizenship ID number that defines a person that never changed. IP address is an assignable address that depends on the different networks related with the network hierarchy. IP addresses are like postal addresses that indicate which street, which city, and which country that a house is located on. You have different addresses at home, at work, which depends on your position, and your device has also different IP addresses which depends on your connected network. But your citizenship ID number is never changed, and your device MAC address is never changed also. Source device is the network device which starts the data transmission. Destination device is a network device to which the data produced by the source device is sent. A connected device can be a source device or a destination device depending on the direction of data generated on the network. Data packets are citizens of the network world. This world strives to make these citizens comfortable and ensure that they arrive at their destination correctly, safely, and with integrity as soon as possible. Of course, with lots of network protocols. Data transmission is the exchange of information between network devices. Data transmission refers to the movement of data in form of bits between two or more digital devices. This transfer of data takes place via some form of transmission media, wired or wireless. This refers to data transfer rate (DTR), which is the amount of digital data that moved from source to destination in a given time. The data transfer rate can be viewed as the speed of travel of a given amount of data from one place to another. In telecom, data transfer rate is usually measured in bits per second. As you see that, data transfer rate is also refers to bandwidth or bandwidth rate. Bandwidth measures by bit per second. As you see on the screen, we use different USB versions like USB 1, USB 2, USB 3 or USB 4. Related with the current version's name that had different data transfer speed rates, which shown by bit per seconds. A similar data transfer rate is used for copper wire cables used for data transfer. CAT means the category and the numbers refers to different data transfer speeds. In general, we use copper cables that support the CAT6 standard, which data transfer speed is 1000 megabit per second. And the greater the bandwidth of a given path, the higher the data transfer speed rate. The numbers of bits, which making up a byte, is processed as a unit by a computer. Bytes are the smallest operatable units of storage in a computer technology, so the stored data size is measured by bytes. Data transfer speed measures by bit per second and data size measures by byte. The data storage capacity of the external disks you have used is also defined by bytes. And the data transfer rate also external disks you use is defined in bit per seconds, which is BPS. As a result, data storage capacity defines by volume of data, while data transfer rate by speed. As you see, with the help of the basic structures that's specified as network devices, data transmission, source devices, destination devices, data speed and storage values, data transmission processes can be defined all over the world. Data transmission is the transfer of data from one signal device to another. These data transfer measures by the bit per second. When the data reaches the destination, the stored data measured by bytes. It's important to pay attention to the measurement values between speed and storage of data. Data transmission modes define the direction of data flow from the source device to the destination device over the network. This data communication mode specifies the direction of data flow from one connected device to another. In general, three types of mode defined to show the direction of these data exchanges. The first one, simplex data transmission mode. Second one, half-duplex data transmission mode. Third one, full-duplex data transmission mode. Simplex is the data transmission mode in which the data can flow only in one direction. In this mode, a sender can only send data but cannot receive it. Similarly, a receiver can only receive data but cannot send it. Radio and TV transmissions are the examples of simplex mode. Half-duplex is the data transmission mode in which data can flow in one direction at a time. In this mode, each station can both transmit and receive data, but not at the same time. These roles can change between sender and receiver, but after retrieving the data. In this type of transmission mode, the entire capacity of channel can be utilized for transmission. Transmission lines can carry data in both directions, but the data can be sent only one direction at a time. Walkie-talkies and radio communications are the example of half-duplex mode. Full-duplex is the data transmission mode in which data can flow in both directions at the same time. It's two-way communication in which both the connected devices can transmit and receive data simultaneously. Full-duplex mode has double bandwidth as compared to the half-duplex. The capacity of the channel is divided between two directions of communication. This mode is used when communication in both directions is required simultaneously. Telephone network in which both the persons can talk and listen to each other simultaneously is the example of full-duplex mode.